Okay, so this is 2 and this is 1. Since this is 2 and this is 1, can you straight away tell me what is the ratio of area for OTP over here to the one in green? What is the ratio of the area? Yellow to green, how much is that? Yellow to green, how much is that? Huh? Yellow to green now, obviously yellow is bigger. 4 is to 1? 4 is to 1?
You know, they never say similar.
No, they never say similar. Huh? So how can it be 4 is to 1? They never say it's similar.
So 2 is to 1 or?
2 is to 1 oh? Yup, Sophia is correct. They have the same common height. These are not similar triangles. So I know that the ratio for area will be 2 is to 1. So what about for this area over here? How much is the purple one? 3, very good. This must be 3 units. Okay, so for example, if I ask you for QTP to the whole parallelogram, it will be QTP, the small triangle to the whole parallelogram. 1 is to 6, okay, good. Okay, so anyway, that isn't the point of the question. Given that OP is 4U and OR is 3V, express PT in terms of U and V. Okay, PT. Where is PT? Okay, this is our PT. Part A. Definitely, I need to express it in terms of some other vectors. Because I cannot straight away get my PT just like this. So let's express PT in terms of 2 other vectors, which we think will be useful for us. So how would you like to rewrite PT? Obviously you must start from P lah, okay? Then must end somewhere, then must be a blank, and I must end at T. So fill in the blank over here.
Negative O,
P, O?
yeah, negative PO.
So you are suggesting that we break it out into these 2 vectors?
Yeah.
Okay. PO, we can do it right. So it is just negative OP. But what about OT? How much is OT?
Right lah. Why 2?
Where is this OT? OT is over here.
Oh yeah, 2.
So how do I express OT in terms of these 2? So now you tell me what you know about OT. Based on the diagram. Rewrite OT now. Okay, it is 2 over 3 of what? OQ. All agree with this? Sophia agree?
Why OT suddenly become 2?
Huh?
I don't understand
Why OT is 2 over 3 OQ, is it? See OT over here, right? This is actually 2/3 of OQ. You must be very quick at rewriting vectors. Okay, now OP, we know that it is 4U. So this one I replace it with negative 4U, then plus 2 over 3. Now OQ, how do I rewrite OQ in terms of 2 other vectors? So it must be from O to something, then something to Q lah. Okay, what is the blank over here? Huh? You want it to be P?
Yeah.
Okay, let's try. OP plus PQ. Okay, looks like it's gonna work. Negative 4U plus 2 over 3. Now what is OP? What's OP? How much is OP? According to our diagram. 4U. Then what about PQ? PQ from here to here is the same as 3V, yeah, which is actually OR lah, because they are parallelograms. Okay, they are the same. So now I have rewritten my PT in terms of U and V already. All that's left is to simplify. So negative 4U plus 8 over 3U plus 2V. Simplify it. 8 over 3 minus 4 is 8 divided by 3 minus 4. We get negative 4 over 3U plus 2V. Get it? Can? Then part B. Prove that P, T, M lie on a straight line. Okay, got some points to say here first. Let me just put it down. PT is actually negative 4 over 3U plus 2V. So to prove that PTM lie on a straight line, there is a variation of this type of question. Very popular question. But they don't say that prove that they lie on a straight line. Instead, they write this. And I want you to copy this down in your textbook. This is the same as prove that PTM are collinear. Collinear means that they lie on the same line. Okay, this is a keyword. It may come up for your media exams, for your prelims, for your O levels. Even if you know how to solve this, then you look at the word collinear. I don't know what is collinear. Too bad you can't do it. So collinear simply means that they lie on a straight line. How do we prove that 3 points lie on the same line? For example, this point, and this point. Do they look like they lie on the same line? No, right? Because if I join it up, it's going to look like this, ma. In fact, I get a triangle lah. They are not on the same line. But let's say I have another point like this. Do they lie on the same line? If I draw a straight line, yeah, they lie on the same line. But how to prove it? How to prove it? Let's call this point A, point B, and point C. We're going to use vectors. How to prove that they lie on the same line?
One direction.
Okay, AB is what? Half of AC. Why must it be half? 1/3 can. So when you say, Hari is saying that we want to prove that AB equals to K times of AC. Because half or 1/3, whatever lah, right? AB is K times of AC. What does this equation tell you?
Find the K.
Not find the K. What does this equation tell us about the relationship between AB and AC? Not yet. Not yet. We've seen this relationship before, right? It is a scalar multiple. Therefore, there are two things you can tell. First thing is that AB is parallel to AC. This is the first thing we can tell. Second thing is that AB magnitude equals to K times the magnitude of AC. I said this last lesson. These are the two things we must know. Now, for the purpose of proving that they lie on the same line, I don't need the magnitude. I need to see that these two vectors are parallel. Only if they are parallel, then there is a possibility that they lie on the same line, isn't it? If they are not parallel, like earlier on I gave you another case, point C like this, AB and AC. If they are not parallel, how can they ever be on the same line, right? So first thing is that the die must be parallel. Okay, so as long as you can rewrite it in this form, AB in terms of AC, yes, they are parallel. But parallel lines doesn't mean they are on the same line. For example, AB and CD. AB and CD are parallel, but they are not on the same line, right? Then how to prove that they are on the same line? Given that I know parallel is one of the requirements. What makes this over here a straight line, but this is not a straight line? Both are also parallel, ma? I give you a keyword, common point.
Oh, the B is it?
Okay, common point, Obviously, everybody can tell me that these three are on the same line, right? Obviously, this one is not on the same line, Why?
Because that one is A, B, B, C.
We still go back to this equation over here. AB equals to K times of AC. I know that they are parallel. Is there a common point between AB and AC?
A.
Yes. What is the common point? A. Exactly. A is a common point. Over here. Between AB as well as AC. So two things are required for you to prove that they are collinear. That is, the two vectors are parallel plus there is a common point. Then I prove that they are collinear. That's how we do it. So that is the approach, and therefore, if I want to prove that PTM lie on a straight line, I must write down two vectors. One vector in front in terms of the other vector. Something like this. So in part A, we already found PT, right? PT is over here. P and T. So what you need is therefore to find another vector such that I can write PT equals to K times of another vector. Where is P and T? P is over here, T is over here, and they want you to prove that M, they all lie on a straight line. Which other vector can you write down really easily? It includes the letter M. QM. But it must be in terms of P, T and M lah. It must include M. PM? PM. Can you write down PM easily?
Yeah.
Okay, let's write down PM. PM equals to? Equals what?
KTM.
P,
PT.
T, then? Once you write PT, then you cannot continue already. Because you are supposed to relate it to PT, so you cannot use PT. Okay, so P what? What is the intermediate point? PQ, okay. Then plus QM. Do you think this works? Okay, then how much is PQ? Huh? 3V, okay. What is QM?
2.
2U? Sure?
Negative.
Negative 2U? Because wrong, different direction, right? Okay, so now PM is equals to 3V minus 2U. Then this over here, let me use some colors to help us remember. Okay, so I've got PT in yellow color already, that is this side. I've got a vector PM over here, which is over here in green. Compare the yellow and green vectors. Are you able to write one in terms of the other?
Yeah.
Look at the coefficients of the U and the V. Do they look like they have something in common?
Coefficient of U is negative.
Okay, coefficient of U is negative. You see that over here I got in green color one, I got U then V, right? U comes before V. So how about I just swap these two?
Oh, so
I just write it as negative 2U plus 3V. Still the same, right?
so the coefficient
Same, right?
is the same as
No, the coefficient is not the same yet. I mean, it is not the same. Not yet, they are not the same. So now compare the yellow and the green one.
negative.
Does it look like you can write PT in terms of PM?
Yes.
How? PT equals to how many times of PM?
Times
So
Oh,
what is
two-third,
what is
two-third.
this blank over here?
2/3.
2/3? Is it true?
Yeah, but it times
2/3 times 4/3. No, I don't think I will get 3. So meaning we are trying to find the blank over here. PT is supposed to be negative 4/3U plus 2V is supposed to be equal to a blank PM. So PM is 3V minus 2U. Okay, now you tell me what is the blank over here that that brings me from negative 4/3. Why am I still writing the wrong one? This is negative 2U plus 3V. That brings me from negative 4/3 to 2. How do you get the blank? How? Tell me how. I want to know the method. I don't want to guess and check. So apparently this unknown over here times this negative 2 gives me my negative 4/3. What is that value?
2/3.
Is it 2/3? You can use, okay, very smart are you? You can use the 2V and the 3V. Okay, this is what Harif is saying. How about we just compare the coefficients of V instead? What over here multiplied by 3 gives me 2. So what is it? 3/2 is this? Is it?
Yeah.
So you look, just mental sum. 3/2 times 3 can give you 2. 3/2 times 3 will give you 2. No, right? So what must it be? How about 2 over 3? 2 over 3 times 3 will give you 2 or not? All start thinking. 2 over 3 times 3 will give you 2 or not?
Yeah.
Yes, right. Okay. Now I need to check whether it is the same over here. Negative 2 times 2 over 3. How much is that?
Negative 4.
Is it the same?
Yes.
Then it's correct already. Okay, but this is like a guess and check, right? Which I strongly discourage. So this was expected to be k. It is an unknown.
Also, you just find K.
Yeah, just write an equation lah. Why do until so difficult? So originally I would have said negative 4 over 3 equals to negative 2k. So k equals to negative 4 over 3 divided by negative 2. But Harif would have said, hey, don't compare this one lah, so difficult to compare. Let's compare something else instead. 2 equals to k times 3. K equals to 2 over 3. Understand? Okay, once I am able to write it in this form, this is 2 over 3. So now, I say that PT, this is my summary, PT is equals to 2 over 3 times of PM. So what if I can write this? What is your conclusion from here?
PT is a straight line. PTM is
Not yet. You need to tell me something first. Since this is equal to this, what can you tell me about the two vectors PT and PM? PT is parallel.
Oh my god.
What is this? So PT is parallel to PM. Since PT is parallel to PM, and the next point, what is it?
PT and
No, common point. What is the common point?
PT.
See lah, P over here is common, isn't it? Since these two are parallel and P is a common point, then P, T, M lie on a straight line. Alright?
So practice paper.
Yeah. Okay, try 27. OA is 5P minus 2Q. So always when you read, go back to your diagram. OA is 5P minus 2Q. Okay, done. OB is 2P plus Q. 2P plus Q. CD is P minus Q. Oh, this little bit over here. Find AB in terms of P and Q. AB, straight away right now already. AB equals to A to B. Instead of going directly, what is the intermediate point? O. So AO plus OB. Then I do some mental sums, okay? I hope you all can follow up. AO, that is negative 5P plus 2Q. Negative 5P plus 2Q. Then plus 2P plus Q. So negative 5 plus 2, that's negative 3P. 2 plus 1 plus 3Q. That is AB. Part B. Show that AB parallel to DC. How to show that they are parallel?
Do the
Write one in terms of the other. So this is a clue that they are telling you, try to write AB equals to K times of DC. This is what they want you to do without actually telling you that. So I already have AB. What is DC? AB, AB is over here, right?
So just find K lah.
Yeah, find K. So since I already have AB,
So
we want to prove that it is parallel to DC. Parallel to DC means parallel to CD also, right?
yeah.
So you can choose lah. Do you want to prove that it is parallel to DC or parallel to CD? They gave, we already know AB, this direction.
Actually DC.
So you want to prove it is parallel to
DC.
DC, same direction. Yeah, I also agree I should prove that it's in the same direction. Okay, now DC is equal to, what is DC?
Negative P minus Q.
Negative P plus Q. Now you compare our AB and our DC.
So negative 3P.
Okay, write one in terms of the other. Which one You want to write AB equals to something DC, or you want to write DC equals to something AB. Your choice. Really your choice.
Then after you just work backwards, find K.
Which one do you want?
AB.
1 or 2?
1. 1.
Okay, I show you both. Okay, number 1, we get AB is, can you tell me the value? What is the value over here?
K.
How much? What's the value? K. Okay, then tell me what's K lah. 3. Very good. Can you see that it is 3? Okay, good. So this means that AB, okay, they don't want just a vector, just scalar. AB parallel DC. Done. Shown. Okay? Now, the alternative, I said that you could try DC equals to something of AB, right? What is the something over here?
K.
Okay, it will be a K, but what is the value of K? It's no longer 3. 1/3. Right? DC over here. This is actually 1/3 of this. Divide by 3, you get 1 and 1. So from here, I can still conclude that hey, DC is parallel to AB. Because I am able to write it in this form to prove that they are parallel. Can? Next. If the area of ABC is 36, ABC 36, find the area of ACD. ACD. ACD is over here. You should be quite fast at this already. We did so many practices already. We require our previous value. We said that AB and CD. What's the relationship AB and CD? They are parallel, right? AB and DC are parallel. What is the scale factor? 1 is to 3. Which one is 1? Which one is 3?
1 is DC.
This one is 1. This one is 3, right? So what is the ratio of area? Are they similar triangles? Are they similar? No. Do they have common height?
Yes.
Yes. So the ratio of area must be
The common height is which one?
1 to 3. Common height is found here. I drop, let's say I want a common height, I want the height for A, C, B, with this as the AB as the base. This will be my perpendicular height. Then this will also be my perpendicular height over here. Same perpendicular height. Okay, erasing this. So the ratio of the area must also be 1:3. Then they told us that, hey, actually this is 36 lah. So what must this be?
36 divided by 3.
Which is 12. 1 second can do already. Okay, so this over here we know it is 12 square centimeters. Given that P is -2306 for Q, express AB as a column vector. AB as a column vector. So for D part 1, AB is equals to AO plus OB, which is negative of OA. 5P minus 2Q, then plus OB, right? Which is 2P plus Q. Combine them together. Did we already find this?
Yeah.
Yeah, we did. Yeah. AB. No wonder it looked so familiar. Negative 3P plus 3Q. Then we just substitute in these values. Negative 3. P is negative 2, 3. Plus 3 times of 0, 6. Which is negative 6, positive 6 plus 0, negative 9. Negative 9 plus 18. So 9. This is AB as a column vector. Finally, calculate the magnitude of CD. Magnitude of CD. CD is actually is it the same as AB? Is it the same magnitude as AB? No, it is actually shorter, right? It is actually 1/3 lah, the magnitude of AB, which you can calculate by yourself. Alternatively, we can write down CD is equals to, since it is P minus Q, or rather Yeah, P minus Q. We can find out the value. P minus Q, negative 2, 3, minus 0, 6. Then after that, you find the magnitude, which is your square root, blah, blah, blah. And then you can do it yourself. Can? Am I going too fast?